Let's take a look now at the case when the last characters are different. This is a situation in our original example. xi is not equal to yi. A is not equal to b. Now in this case, when xi is not equal to yi, the last character of the longest common subsequence can either be a or b, or neither. Certainly cannot be both. Now suppose it's a. For example, suppose this is the last character in the longest common subsequence. Then what do we know about yi? B. Well, b has nothing left to match with in x. Therefore, we know the LCS does not include b, yi. Similarly, if the last character is b, say it's matched with this b, then the LCS cannot include a, because it has nothing left to match with in y. The key point is that the longest common subsequence for this prefix of length I either does not include xi, or it does not include yi, or both. So either xi is dropped, or yi is dropped, or both of them are dropped. Now let's consider the three cases. If both of them are dropped, then we can simply take the longest common subsequence in this prefix of length I minus 1. So it's similar to the equal case, except we don't get this plus 1 here. Now what happens if just xi is dropped? Well, then we have a prefix of length I minus 1 in x, and a prefix of length I in y. So we have no way of looking this up in our table. The solution to this subproblem is not in our table, because the prefixes are of different length in x and y. And notice, even if we knew how yi is matched up with in x, for instance, if we knew this b was matched with this b, then we have a prefix of length 3 in x, and we have a prefix of length 6 in y. So they're still of different length. And similarly, if yi is not included, so we drop this last character from y, then we have prefix of length 7 in x, and a prefix of length 6 in y. So the prefixes are of different length in x and y. And once again, the solution to this subproblem is not in our table, because these prefixes are of different length. So for this case where yi is dropped, we need to look up the longest common subsequence in the prefix of length I in x with the prefix of length I minus 1 in y. Now this isn't in our table presently. And similarly, when we try to solve this subproblem, well then we might chop off the last character from y, and then we get an even shorter prefix in length y. So for this subproblem definition, we are unable to define a recurrence. We are unable to express L of I in terms of smaller subproblems. But we got some insight about what is a good subproblem definition. The difficulty here was that the prefixes are of the same length for x and y, but we need to allow them to be different lengths. So how do we achieve that? We're going to change from a single parameter I to a pair of parameters I and j. I will correspond to the length of the prefix in x, and j will correspond to the length of the prefix in y. And our table will now be a two-dimensional table. So L of ij will be the length of the longest common subsequence in x1 through xi with y1 through yj. And we're going to try all possibilities for I and j.